All right, welcome to Unit 3, Lesson 4, Part 2. There are really only two questions or two examples that we need to do to finish off this lesson. So let's dive right into it. We left off at writing the equations of the sine function, okay? So example 1 says, sketch one cycle of a sine curve with an amplitude of 1/3, okay, so that's kind of important, and a period of pi. So when I sketch this graph, okay, then it also tells me to write the equation of the curve, and we will. I'm going to do this like I would do anything else. My amplitude is 1/3, all right? I don't know the frequency, but I know the period. The period is pi. And although we know that pi equals, I'll be okay. Period equals 2 pi over frequency. Period and frequency are kind of like the same. I don't want to say synonymous, but in the terms of the equation here, I can also switch these two and say frequency is 2 pi over period. Yeah, I'll be okay, and my period is pi. Whew. It's a lot of P words right there, children. Okay, so what we have is we can switch our P and our F. All right, so I'm actually going to use this to find my frequency. So frequency is 2 pi over period. That means it's 2 pi over my period is pi. And the beautiful thing about that is the pi's cancel. Man, that's saying pi a ton. All right, so my frequency is actually 2. Okay, my period is pi, my frequency is 2. And the midline, it doesn't say anything about moving up and down or left and right. We're not even there. So I'm just going to sketch it based on what I have here. All right? So, a lot of explaining for early in the morning. All right? What do I know? I know that my midline is still going to be 0. Okay? It's still going to be y equals 0. There is no change. My amplitude is 1/3. So I'm going up to 1/3, and I'm going down to negative 1/3, all right? And the period is pi. So that means the length of one cycle is going to be pi. Half of that is pi over 2. Half of that is pi over 4. And if I do this right, I add pi over 4 to pi over 2, that's what I should get here. And keep in mind, if I add fractions, the bottoms need to be the same, right? So if I multiply this bottom by 2, I got to multiply the top by 2, and I end up with 2 pi over 4 plus 1 pi over 4, and that gives me 3 pi over 4. All right? That's a little bit of algebra mixed into trigonometry. No biggie. So I'm just going to write this just like I would. I'm going to sketch this. Let's not forget, here's our 0. Starts at the midline. It ends at the midline. And in the middle, it's the midline. Goes up to 1/3, down to negative 1/3, and I sketch that. Bam, perfect sketch. Look at you go this early in the morning. But we're not done. Because not only do they want us to sketch the curve, they want us to write the equation. I know this is a sine curve. I know it's positive. It's not negative. It's not flipped. It's positive sine curve. So y equals something sine, okay, of x. My amplitude goes here. And my frequency goes here, which my frequency is 2. That's why we did frequency. When we were sketching this, you might have been like, why did we even have to do frequency? Because we need it for the equation. Bam. And that's your equation of the curve right there. All right. Example 2. Let's do this last example for these two, this function A and function B, and we are out of here. Okay? So, find the period for each of the sine curves below. And then it says the right instead of then write an equation for each function. Okay, let's fix that because we ain't no English people. Then write an equation for each function Okay, each graph goes from 0 to 2 pi. That's important. Okay, so this starts at 0, and it goes all the way to 2 pi. So the first thing they're asking us to do is, okay, find the period. The period, again, is 2 pi divided by the frequency. Remember, these are interchangeable, okay? I could put f equals 2 pi over p, and I could find the period, all right? So, yeah. Where is it? I took, no, there, one more. There it is. Wow, took everything off. There we go, that's what I wanted. So, p equals 2 pi over the frequency. So how can I tell the frequency? Let's look at function a. How can I tell what the frequency is? By definition, the frequency is the number of curves in 2 pi. So the number of sine curves, okay? So if I start here, I go up, I go down, and boom, that's one sine curve. Now, as I start again, I'm starting a second sine curve. Up, down, boom, that's the second sine curve. Remember, sine curve is the S. That is one sine curve. There are two of those here. So my frequency is 2. So if I want the period, it's 2 pi over 2, okay, which means pi, because these cancel. And doesn't that make sense? This is pi. Period is the length of one curve. And absolutely, 100%, one curve goes to pi. And that's what we figured out. That's the period. That's the first thing we need. The second thing is we need to write the equation for this. And that really is much simpler than you think, especially now that we figured out what the frequency is. Because remember, it's going to be y equals the amplitude in front of sine, the frequency in front of the x. Now, this isn't up or down. The midline is still at y equals 0 here, okay? What we need to figure out, we know the frequency is 2. That goes here. What's the amplitude? That's how high and how low this goes. Well, it goes up to 2 and down to -2. Yes, the increments are by ones. So that goes up to 2, and then it goes to -2. Okay, so the amplitude is 2. It goes 2 up and 2 down. That's your equation right there. Okay. Let's take a look at function b. Now, they want us to find the period. Again, period is 2 pi divided by the frequency. So I need to figure out the frequency. So how many cycles? Again, these start at 0 and they go to 2 pi. So the frequency is how many sine curves do I see in 2 pi. So let's start this out. We have the S. Oh, it goes down, so this is going to be negative. Boom, there's an S, so that's one sine curve. Boom, there's a second sine curve. Boom, there's a third sine curve. And last but not least, 4. There are actually 4 sine curves. So my frequency is 4. That's going to help us write the equation, and that's also going to help us find the period. Okay? The period is 2 pi over the frequency, which is 4. 2 goes into 4 twice, so it's pi over 2. The length of one curve is pi over 2. So let's kind of make sense out of this. If this is 2 pi, the halfway point is 1 pi. Half of 1 pi is pi over 2, and absolutely that's the length of one curve, pi over 2. So we did it, okay? You don't have to go and check it. I like to show you how we got the equation and how it relates to the graph so you can better understand it. But you don't have to do that to solve the problem. Now, last thing, our equation. We know it's y equals, we have the amplitude, we have sine, we have the frequency of x. Because my midline is still at 0. All right? The one thing you need to notice, and the one thing that I mentioned earlier, is that this sine curve does not start going up, then down. It starts going down, then up. So that means it's a vertical flip, which means my sine should be negative. The negation of my amplitude times sine. Frequency is what? 4. So all we got to do at this point now is find the amplitude. If these are increments of 1, that goes to positive 1 and negative 1. So it goes up and down 1. So you can write 1 here. You don't have to. I mean, that's an acceptable answer. If this was short answer, that's good. But if it was multiple choice, they would not write a lead 1. They would just say y equals the negation of sine of 4x. And that's how it would be written for multiple choice. We are done with lesson 4. Godspeed, good luck, and I will see you for unit 3, lesson 5. Cinco in Spanish, cinque in Italian. That's cool. Cinco's cool. A lot of cinco. But cinque in Italian, you got to hear an Italian person up to 10. It's fantastic. Maybe for lesson 5, I'll do that. Maybe not. See ya.